Mr. Schultz here as we dive into solving quadratic equations a different way. We're going to solve them by using the quadratic formula. So, what is this? Well, right now, go ahead and pause the video and go on YouTube and search quadratic formula song, and you should hear some earworms that will teach you this quadratic formula. Like some are in some pop songs, one's even Pop Goes the Weasel, and you just memorize this formula and then understand what does this mean. So here's the formula. X, our solutions, will equal negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a, and we'll figure out where does the quadratic smash into the ground, or what are the solutions for when y is 0? What are the x values? Here we go. Now, this is when we have it in standard form, like ax squared plus bx plus c is equal to 0, where a cannot equal 0. So let's dive into our examples. So we have x squared plus 8 plus 15 is equal to 0. So what we're going to do is we're going to write this out. We know that our solution should equal negative 8 plus or minus the square root of b squared, so 8 squared, minus 4 times 1 times c, which is 15. So these are multiplying right here. And then we're going to divide all of this by 2 times 1. So let's scroll down and go ahead and you try to solve this. Go ahead and pause. Here we go. 3, 2, 1. All right, so here's our solution set right here. We understand that, hey, plug and chug. We do each of the steps and we make sure we follow GEMDOS. We do squaring, then we do multiplication, and then we subtract it. Then we do the square root. And then we get two solutions right here, plus or minus the square root of 4, plus or minus 2 to both right here. And so we get our solutions of negative 2 or negative 5. So when x is negative 2 or negative 5, the parabola is going through it. Now, if we look at this right now, this in purple is the discriminant. We're going to come back to this. This is a positive number, and we're going to see, hey, look, we got two solutions here. We're going to come back to this. Two real solutions. Let's go on. We got x squared plus 8, x plus 5. So once again, all we have to do is we have to write out our formula. Negative b plus or minus the square root of b squared minus 4ac. And we divide it all by 2a. Well, now that we've written that out, what we're going to do is plug and chug. So I have x is equal to, go ahead and pause it if you'd like. We're going to continue in and see if you get the right answer. And we're going to continue in 3, 2, 1. So I'm going to get negative 8 plus or minus the square root of 8 times 8 is 64 minus 4ac. A is 1, B is 8, and C is 5. Something that might be helpful is if you write this out so you don't get mixed them up. So 4 times 1 times 5 is 20. Okay, cool. Now I'm going to divide all that by 2a. Well, 44 divided by 20, or subtracted by 20, would be 24. And so I'm going to have the square root of 24 plus or minus into this negative 8, all divided by 2a. Well, square root of 24 is not nice. This is actually, 8 times 3, or 4 times 6. So if we were to actually, pull this out, I'd have negative 8, square root of 4 is 2, plus or minus 2 radical 6. And then it's 2 times 1 is 2. Now I can make this two different fractions. So I have x is equal to negative negative 8 divided by 2 is 4. And then 2 of these divided by 2 is 1. So I'm going to have 4 plus radical 6. And I'm going to have or x is equal to 4 minus radical 6. Well, in this case, I'm going to have two answers, but they're going to be two solutions, but they're going to be radical. They're not going to be nice numbers. They're not going to be counting numbers. They're not going to be whole numbers. They're not going to be integers. They're going to be radicals or irrational. So in this, it's still this radical right here. Let's circle it right here. The discriminant right here is positive. So this b squared minus 4ac is still positive. It's still larger than 0. So at the moment, I'm still going to get two solutions. However, they're not nice. They're irrational. Let's go on in 3, 2, 1. All right. I realized I made an error right here. This is going the wrong way. This should be, hey, this is bigger than 0 because it's 4. So this guy right here is 4. 4 is bigger than 0. All right, now let's go on. So next example, we have this x squared plus 25 is equal to 0. Well, if I remember my formula, I'm going to have it right now in 3, 2, 1. Here's my formula. Now I just need to plug and chug. Now I know that a is equal to 1, b, I ain't got no b, so it's going to be 0, and c is equal to 25. So now I just do plug and chug. I have x is equal to 0, negative 0, plus or minus 0 squared, minus 4 times 1 times c, which is 125. So this would be 100. And I'm going to divide this by 2 times 1, so 2. So if I simplified this, I'd get the square root of negative 100 over 2. Wait a second here. Plus or minus. X will equal 10i divided by 2 plus or minus. It's going to equal 10 divided by 2. 10 bunnies divided by 2 is 5 bunnies. So instead of bunny, it's I. So positive 5i, or x is equal to negative 5i. So in this instance, we have two imaginary solutions right here because the graph's not going to connect. And why is that? What if we notice right here? If we look right here, our discriminant, or the expression underneath, we have this b squared minus 4ac right here is actually going to be smaller than 0. So if it's smaller than 0, it's going to be negative, and we can't find the square root of a negative number. It's imaginary. It's fake. So in this situation, we'd have imaginary roots. Let's go on. So what if we have this? Let's plug this into our quadratic formula and figure it out. I'll pause right now, but I want you to try to do it. Go ahead. So I have 64 minus 4 times 1 times 16 plus or minus square root of that, plus or minus this 8 all divided by 2. Well, I'm going to get 8 divided by 2 plus or minus, this is 64. 4 times 16 is 64. 64 minus 64 will give me 0. And the square root of 0 is 0. So I got 8 over 2 is equal to x. Why is that wrong? I didn't simplify. So x is equal to 4. Now in this case, I only have one solution. So what's the what does our discriminant have to equal? What does b squared minus 4ac have to equal to give us one solution? It has to equal 0. And if it does, congratulations. We have a quadratic that barely touches the line. And so our solution is 1 at the vertex point, either pointing up or pointing down. All right, guys, let's jump into our discriminant chart we're going to make now. So discriminant, the expression under the radical sign. And this is for, the quadratics like ax squared plus bx plus c is equal to 0. So let's fill it in. All right, guys, so here's our discriminants. This is where, we have the square root of b squared minus 4ac. So if we just look at that right now, we can tell, how many solutions it is and what the graph should look like. So if it's bigger, if this discriminant is bigger than 0, meaning it's positive, it's going to have 2 solutions. Now, we won't go into the exact one, but they could be either rational. So if we just say the square root of 4, that gives us 2. And we're like, yeah, because then we can add and subtract and get some rational numbers. Or it could be irrational, like the square root of 3. And if we get into that category, it probably won't be as nice, but it's okay. Now, if we have b squared minus 4ac is equal to 0, if the discriminant is equal to 0, then it's going to have one solution. And finally, if it's negative, it's going to have 2 complex roots. Now, what does this mean? Well, that was like 2i, or it's going to be like, 2 plus I, or something like that. So let's show you what that looks like. Well, 2 solutions looks like this. It crosses the x-axis twice. One solution looks like this. It barely touches and it comes back up. The vertex is resting on the x-axis. And finally, with complex roots, we're going to have the parabola not even touch it at all. It's imaginary. Where does it touch? It's imaginary. It never does. All right, guys. That's it for today. I'll catch you guys in class.